Assalamu alaikum. This is Sayyid Mohammad Talha, and today I'm going to discuss a research paper by Nada Elgendy and Ahmed Elragal. It's based on big data analytics. So let's begin. Imagine a world without data storage. Imagine that every transaction that we do right now that is documented, everything in organizations, etc., was never stored. Pathetic, right? So it's a good thing that we collect data and we store data and we don't lose it. And that's why data growth around the world is exponential. And nowadays, data is increasing so rapidly that in the last decade, it never increased at this rate. The data from social media sites, the data from different transactions and point of sale applications, millions of applications are producing millions of bytes of data every day. So that is giving rise to bigger data sets. The data sets that we have been previously working on wasn't very big in size, and it was, it was handled easily in comparison with data sets to today, which are very big in size. For example, they are in multiple petabytes. So it's not easy to store this data and analyze this data in a traditional environment. So this is the main focus of this paper, that data sizes have grown rapidly, and storing them and analyzing them is a big task at hand. So the term big data, what is big data? Big data refers to data sets that grow so large, so large that it becomes very difficult to work with them and to handle them. And traditional databases especially cannot handle them. So there are data sets whose size is so big that sometimes not even a single system can store it. And so data size of big data is increasing. One of the things about big data is its size is already too big, and it's increasing, it's changing. So one of the properties of data is that its size is not constant, it's variable, it grows, it keeps growing. So this is why big data is in limelight nowadays, because everywhere data is being populated, and if we didn't have tools and techniques to store this data and analyze this data, especially analyzation, that data would be useless, it would be garbage, we would literally dispose of that data. But big data analytics is a thing, thankfully. So we're going to dig deeper into that eventually. So what are the characteristics of big data? We're going to discuss its 3 V's. 3 V's of big data are volume, velocity, and variety. Sometimes there are 4 V's or even 5 V's, the 4 being veracity and etc. But we are going to discuss 3 V's here because the research paper discussed 3 V's. The volume of big data refers to its size, its actual size in bytes. So the more volume it has, the more the size is, obviously. The velocity of the data refers to the rate at which it's growing. So we know, as I've already discussed before, that the size of big data keeps increasing. So the velocity refers to the rate at which it grows. And finally, variety, the third and last V of big data. It refers to data coming from different sources, multiple sources, different kind of data, heterogeneous data, and getting stored in a single data set, in a single place. So variety, the word variety, as it says, refers to the different data that is stored in a big data database or data set. Okay. So let's talk about big data analytics tools and their methods. So big data cannot be easily analyzed. You cannot analyze big data with the tools and methods that were used to analyze traditional databases. So a big data analytics and decisions framework was proposed. It incorporates the big data analytics tools and methods, and it maps the differences big data has with the traditional data. And it's still evolving. It's an evolving field, and so the MAD analysis for big data refers to magnetic, agile, and deep analysis skills in context of big data analysis. So it is different from our traditional enterprise data warehouses environments, and traditional database environments discourage data coming from multiple sources, and if it's of different type. But in big data, it is appreciated. So Hadoop is one of the tools used to perform analysis and store big data, and it provides reliability, high scalability, and easy manageability. And it basically consists of two components. One is the SDFS, and other is the MapReduce. SDFS is the storage unit. It is a function that provides reliable distributed storage systems, and it stores data in a distributed format, meaning that it doesn't store data in a single system. It breaks down the data and it stores the data in different chunks. And there are two types of nodes in SDFS, the data node and the name node. The data node consists of the data, the main data, and the name node consists of a key, sort of a key. So it's sort of a key value thing, and the same data is referred with a single name. For example, there are 10 kinds of different same data, 10 reference, and will be only a single name that references those 10 data. So it is managing the storage of data very efficiently and trying to reduce the usage of maximum storage. So the analytics part of big Hadoop is with the MapReduce. So the MapReduce function within Hadoop depends on two different nodes, the job tracker and the task tracker nodes. The job tracker nodes are the ones which are responsible for distributing the mapper and reducer functions to the available task trackers, as well as monitoring the results. So the MapReduce job starts by the job tracker assigning a portion of an input file on the SDFS storage to map a task running on a node. On the other hand, the task tracker nodes actually run the jobs and communicate results back to the job tracker. So this is a small summary of how Hadoop uses MapReduce and SDFS to perform high performance analytics. So the most important part of big data analysis is decision making. So we all know that as the data size increases and the bigger the data is, and if we really have an efficient ways to analyze data, then the decision making will be best, because the more the data, the better the decision making. So how big data helps in decision making? So we know that social media creates tons of data every day. And how do Facebook, Twitter, and Snapchat and other social media sites uh, benefit from that data? And how do they make decisions? So they perform usually sentiment analysis and other kinds of analysis, hate speech, etc. And they filter some words, and they observe patterns in the data, and that helps in narrowing their advertisement markets, and narrowing the things they need to show people in the advertisement bar. It helps them to suggest good friends and closer friends. It helps their AI pick hints. So and with customer intelligence, it's evident that all sites, Daraz and Amazon and Alibaba, all kinds of stores which are used by millions of people all over the world every day. They store that data. Alibaba, Amazon, eBay, they store that data, and that data helps in you know understanding the needs of the customer better. For the supply chain and performance management, big data comes in very, very, very handy. So imagine you have a warehouse, and all the details related to it are recorded in a database. And when the regression analysts, etc., the people who are analyzing what could be the best way to manage a supply chain and to maximize the performance of a particular data warehouse, sorry, I'm saying data, of any warehouse. So what could be the best possible way, what could be the best strategy to maximize the performance? Big data comes in very handy here. For quality management and improvement, for products, for companies who work on different kinds of products. For example, let's take an example of Samsung. It works on mm, different kinds of products that billions of people, literally billions of people, use around the world. So they collect that data, the feedbacks and the responses from their customers, and they maintain their quality according to it. They assess the data, they assess from which features their customers are happy, and they assess that which features are not so famous among people, and they make decisions based on that. Big data analysis can also help in fraud detection, and that is really true because the patterns that can easily be observed in big data during big data analytics, I mean, they can easily tell which where the fraud is happening, because there is always a pattern to any crime or fraud scene. So if we really have efficient tools to analyze cases and things, like in police stations and in high security crime scenes, etc., so there big data can help in fraud detection. Tools and frameworks that are constantly evolving for big data storage analysis have opened a new paradigm for people who make decisions. That's true. And big data and related concepts can provide basis for further advancements in science and technology. Big data is the next big thing. And as the data size is growing larger by the day, analyzing it and making decisions based on that analysis is coming in extremely handy for people with power, or for people who are at managing positions in organizations. Thank you. That's all.